after we find out the stress due to all of the 5 forces moment on the cross section, then we can use superposition, add all of that together. So let final step here before we move on to the find the principal stresses and maximum in-plane shear stresses. So add stress block for all the load, right? For all load. Before I move to draw this, I just want to make a correction here. As you can see, the pi cancel out. From that, it should be no pi in here, only 5,120 psi. So let me put that psi here, tension. And the block here, it also have no pi, and we can move up here psi. So let's move on to the add-on of stress block. So we can draw the stress block for A and for B. Stress block for B. And consistently, we use the same XYZ axis at there. That is X. That is Z. And we have that is X. And that will be Y. Then we add them together. Let's talk about A first, and then we move to B one step at a time. So at A, you have the first one, sigma 80 psi, tension, nothing. Tau SY. We talk about sigma first. Due to my, nothing, and 5,120. So as you can see, 80 plus 5,120, we have the sigma x. It both are in tension. So that one, it will be 5,200 psi. And for A, in terms of the shear stress, tau SY, let's go. The first one, Fx, nothing. For block Y, look at block A, nothing. Tau xz, 320 psi, nothing. We already consider that normal stress, so it's 320 psi, and that you can see it from here, and positive in the x-plane, so we can have that here. 320 psi, and that of course is going down. Just change the direction. So that done for the stress block. Do the stress block for point A, and similarly we do for point B, and look for the normal stress first. 80 pounds tension. This is shear stress. 1,820 psi, also in tension. So from that we have, and in X, so it will be here, 80 plus 1280, so it will be 1360 psi for sigma X. Now tau XY for this one, nothing. Yes, and negative 53.3 ksi. Tau xy. Tau xy in here, also negative 320 psi. So nothing. Add them together, so it's negative. It means opposite in your y direction in positive x-axis. Y going down positive, so go up here, go down, go up. And that equal to add up them 53.3 plus 320. So we have 373 psi. So that we have the stress block. When we complete the stress blocks, we can go ahead to find out the principal stresses for point A and point B using the Mohr circle or equation. So I'm using the Mohr circle to review here. So find principal stresses and maximum shear stress. Stress. And use the Mohr circle. And you can see here, we can go ahead to divide by 2, one point A and point B. So we can have A on the left and B on the right. So A, let's go here, we have A and we have B. Then find out the sigma average. Sigma average equal to 5200 divided by 2, that equal to 26 psi, 20 psi. And with that we can go that is equal to 2.6 ksi. If you want, that is 2.6 ksi. And then we have on B, let's do it later. And then we have tau max, which is the radius, equal to tau max, and that equal to sigma average plus tau xy square. So it will be 2.6 square plus 0.320 square, and that equal to 2.6 2 ksi. And similarly, we can find out on B. We have sigma average. From that is equal to 1360 divided by 2, that equal to 0.68 ksi, and radius equal to tau max, and that square root of 0.68 square plus tau 0.373 square, and that r equal to 0.776 ksi. So we can be able to find out sigma 1, sigma 2 with the equation. As you can see, sigma 1 equal to sigma average plus radius, right? Plus radius or tau max. And that plug in, we can have equal to 2.6, 2.62. So it will be 5.22 ksi, and sigma 2 equal to sigma average minus radius and 2.6 minus that, so it will be 2.6 minus 2.62, so it will be negative 0.22 ksi. And tau max it already have there. Tau max equal to 2.62 ksi. And of course you can find out the other side. You have sigma 1 for point B equal to sigma average plus the radius. So it equal to 1.456 ksi, And of course that is intention, as you can see, positive intention. So negative is in compression, or you can say that it's 0.02 ksi in compression. Sigma 2 equal to sigma average minus radius, and that is 0.68 minus point, so it will be 0.96 ksi, 0.096 0.096 ksi negative, and that equal to 0.096 ksi compression, and tau max equal to 0.776 ksi. So that all the answer we have for this problem. And of course you can draw the Morse circle for this as well, Morse circle, and that you should be an expert by now to draw the Morse circle. Again, draw a quick Morse circle in here. We have here sigma, and we have tau. So for, let's move tau on very left here, sigma. So sigma average 2.62, 2.62 somewhere here. Sigma 2.6 and 2.62. So as you can see, it's the 0.02. So the circle, this is sigma 1, sigma 2, and tau max. Tau max. So you can have the circle. For that point, sigma 1. And with that Morse circle at the x plane, 5.2 ksi and 0.32 psi, and in that case negative. So you have the x plane. Let's see, for x, you see x plane here, you see x, and it create counterclockwise, so it negative, as you can see there. So it will be the point go down there. Undo. So you have that point here, positive x plane, and that is y plane at 0. Nothing. If we make the line out through, so it should be here. So we have the x equal to 5.2 and counterclockwise, so negative 0.32, and ksi units here, ksi tau ksi, and this is y, and y of course 0 and 0.32. Similarly, we can draw for point B. Sigma ksi and tau ksi, and we already have sigma 1, sigma 2. So sigma 1 and sigma average, so the center sigma average equal to 1.68 here. Sigma average 1.68, and the radius 0.776, and sigma 1, so it will be This is sigma 1 and this is sigma 2. Tau max equal to the radius, and that is 0.776. So we can be able, again, similar Morse circle that we can find out. And x plane, positive x plane is also 1.36 KSI and 0.373 PSI, and it is counterclockwise, so it's also negative. So here this will be y 0.3773, and go down here we have point x, and which is 1.36 and negative 0.373, and also KSI. So with that, we're done for this problem. By all the question that you can see, it very long process to solve for worksheet 16B, and it will be the same process for 16C.